In the previous video, we made this data frame df3, and the main point of it was that I had restricted this chord column to only contain 4 possible values. So I removed all of the rows from the original data frame that weren't among those 4 values I wanted to keep. And so in this video, what I want to do is I want to use the KNeighborsClassifier classifier from scikit-learn, which I imported up above here using this. I want to use that to try to predict what is the chord of the song, okay, using some of the numeric columns. So I don't think you can use, for your inputs, your x, I don't think you can use non-numeric values. So let's try to do this. And I'm not going to use a training set or a test set just to speed things up a little bit. So let's look at what the data types are in this df3. And if I hadn't imported it using that NA_values keyword argument, then a lot more of these would be object. So a lot more of these would be strings. But since I told it how to recognize the not a number values, now it has automatically converted a lot of these into numeric values. And so I should choose some of these numeric values for prediction. So like for my x, so let me use artist followers. And I'm going to put these into a list. So let me use artist followers, danceability, energy, loudness, and acousticness. Yeah, I think that's all I will use for this. And so then for my x, okay, this is going to be df and then keep only those columns. So we've seen these two different ways of taking just a part of the data frame. Up here, we did df and then a Boolean series. And so that keeps rows. Okay, it keeps the rows where there's a true for the Boolean value. Here we have df, and then we have a list of columns, and this keeps columns. So it's a little backwards that, I mean, I'm not using loc or iloc in either of these, and one of them does rows and one of them does columns. But this is an abbreviation that I've found to be very convenient, that the pandas creators came up with. Okay, so that's going to be like my inputs for this. And then y, this is going to be, oh, and I should have called it df3. And to use what we were doing in the last video, let's also put a copy here. Okay, so that's like saying, make a whole new data frame not connected to the original df3. And so let's look and see how x looks. So it's just numeric values here, but it should be the same number of rows, 646, as df3. Okay, that looks good. And then y, this is going to be the thing we're trying to predict. So this is going to be df3 and then chord. And now I'm going to instantiate one of these KNeighborsNeighbors classifiers. So I'll call it CLF for classifier and KNeighborsClassifier. And when we did logistic regression for the classifier, we didn't put anything in the parentheses. But here it's good to say how many neighbors we want. So let's do n neighbors equals about 4. So you should worry that we might be overfitting in this case, but we'll talk about that in a minute. So now we have the classifier, but we haven't given it any data yet. So now let's fit using the data. So we'll do clf.fit xy. Okay, good. And now we can do clf.predict. And you should be imagining that it would be a little better if I was using a training set and a test set here. So like using training up here and test here. But this way, for what I want to demonstrate in this video, is fine. Okay, good. And now let me take x, and let me say x prediction equals this. So now if I look at X, it has the original numeric columns that I chose, and then it also has this prediction here. And so let's look at it. Let's plot it using Altair. So let me say Altair.chart X mark circle, and let's encode X for energy, Y for, how about danceability? And let's just look at that for now. Okay, so there that is. And now let's look at for color. Let's look at this prediction. So it looks totally chaotic. And I mean, that's fine. The true data also might be totally chaotic in this sense. You notice there are only 4 colors since I removed all the other possible chords back in the first video. So that looks good, and we can't tell that anything is going wrong yet. But let me show you a different viewpoint on this. Instead of danceability, let me get artist followers. And so do you see how kind of peculiar this looks? So notice how all of these are the exact same. Okay, and if I go back to my DF3, okay, this is like the true data. And it's still going to be energy, still going to be artist followers, but there is no pred column, or it didn't have any information in it. This one will put chord for the color. So this is like the true data. So maybe it's helpful if I show them side by side. So, oops. So let's call this one C1. Okay, that's the prediction one. And let's call this one, how about C0? I'll put it on the left. And then let's look at both of these next to each other. So this is the true data. Okay, and this is the predicted data. And so you can see that like all of these up here on this horizontal line, these are all given the same color. Okay, not this one, but all these others. Whereas here you can see that there are lots of different colors. And similarly, like here, these 3 are all the same color. And these 3, these red ones, are all the same color. And so why is that? Well, let's look back at the data we used to fit this. That was X. And let's look at the range of these different columns. So range for danceability and energy and loudness and acousticness. Why, I guess danceability, energy, and acousticness, they're all between 0 and 1, it looks like. And loudness is between -25 and -1, it looks like. Whereas artist followers, these are like between 100,000 and 100 million. So as an example, think about like this little point here, okay, this one here, and think about what does it look like are the, or maybe this point here is better. Ask yourself, what do you think are the 4 closest points to this one? And probably you're going to say, okay, well, it's that one, this one that's right next to it, this red one, and this red one. So probably those 4. But if you look at the scale, this scale is in the 10 million range. Okay, this y-axis legend. Whereas this scale, going left to right, it's in the 0.1 range. Okay, so if I come back up here, to get from here over to here, that's only traveling a distance of like 0.2, okay, or maybe 0.05. Whereas this distance here, it's traveling a distance of like 5 million. So what's the point of this? The point is if you want to use a classifier or a regressor that's dependent on distance, you should really start out by scaling your data. So we'll look at that in the next video.